Hi, my name's Jackson Wiseman.
And I'm Joel Rudder, and we are going to be talking about how kinematics and Newton's three laws of motion are applied in ping pong.
Okay, the first thing we're going to be talking about is speed. Speed is the rate of change in motion. We measured the table, and we found out it was 90 feet. And if you convert that into meters, you get 2.7 meters. The time that it took to serve it was roughly 1 second. So if you take 2.7 divided by 1, you get 2.7 meters per second. That is the speed of the ball. Velocity is the speed of an object in a certain direction. Speed and velocity differ because velocity has a direction, such as north, south, east, west, up, down, left, right. The ball's traveling in a certain direction, which is east, and it also has a constant speed it's going at. That's why it's velocity and not speed, because it has a direction. Acceleration is the rate at which velocity changes over time. This is acceleration because the ball changes speed and direction with the side swing. Friction is a force that opposes motion between two surfaces that are in contact. The role of friction in ping pong is when the ball gets spin. Examples of this is when the ball hits the table, the ball hits the paddle, and when the ball's in the air.
Newton's first law says that an object in motion will stay in motion, and an object will stay at rest, unless a net force is acted upon it. Inertia is the resistance to change in motion. This is Newton's first law of motion because it shows that an object in motion will stay in motion until a net force is acted upon it, which is gravity. Newton's second law is a net force placed on an object with mass causes the object to accelerate in the direction of the net force. Since the ball has less mass, it requires less force to hit it across the table. But using an object with more mass requires more force to hit across the table. This shows that the relation of mass and weight. Since the ping pong ball is lighter, it requires less force to hit it across the table. But if we get a heavier ball, then it requires much more force to hit across, which shows the relation of mass and force. Newton's third law says that for every action, there is an equal and opposite reaction. Basically, what Newton's third law is saying is that the ball hits the paddle, but the paddle hits the ball back, just like the table hits the ball and the ball pushes back on the table. This shows that everything pushes on each other.
Alright, in this video, in the kinematics section, we learned about speed, we learned about velocity, we learned how speed and velocity differ, we learned about acceleration, we learned about friction, and then we acted out examples in every one of those categories. Whoa!
And for the Newtonian part of this, we learned about Newton's first law, inertia, Newton's second law, and Newton's third law, and how they all work in ping pong. So anyway, that was
Nice, Joel. Jeez. You gotta redeem yourself real quick. Nice. Oh, jeez.
Newton's first law of motion is that.
Whoa! Jeez, Joel.
10 points!
Gosh. Whoa.